Hello guys, welcome back to the structural geology course. In today's lecture, we are dealing with rocks and scales, and then we are looking specifically at the homogeneous and the heterogeneous rocks. This is MJ School of Mining and Geology. Don't forget to like, share, comment, and subscribe to our content so that we keep producing this kind of a content. Let's dive right in. Now, in the context of geology, rocks can be viewed as the function of scale, with their properties and characteristics changing as we move from one scale to another. If you are following other structural geology lectures, you by now you'd be understanding the different scales, meaning from microscale, mesoscale to macroscales. And we said that in order for structural geologists to come up with the correct interpretation of a certain area, then you need to combine, all these skills, all right, and you need to understand their relationship, all right. Now, this is because rocks show varying levels of heterogeneity and homogeneity at different scales. So, which is why today we are dealing with heterogeneity and the homogeneity in rocks. Now, homogeneity refers to the absence of variations in composition. They are homogeneous, they are the same, okay? They look the same, then you cannot differentiate between the mineral composition, of course, depending on the scale. But I'm going to show you with the examples what do we mean when we say a rock can be homogeneous depending on the scale, and it can also be heterogeneous also depending on the scale. So it refers to the absence of variations in composition, texture, or structure within a rock. Rocks can be homogeneous at different scales, meaning that they may exhibit different levels of homogeneity depend on the scales at which we examine them. So in terms of the microscale, at the microscale, rocks can be homogeneous if they consist of a single mineral or mineral assemblage. All right. If a rock is monomineralic, then say it's homogeneous because it will just seen with the same composition because it's monomineralic. Sorry about that. Now, but at the mesoscale, rocks can be homogeneous if they have consistent texture or composition. Then if at the macroscale, rocks can be homogeneous if they belong to a single lithological unit or have a consistent structure. If they belong to a single lithological unit, they would still be macroscale. All right. Why? Because if you're looking at a certain lithological unit, that lithological unit, for example, let me give you example wherein we've got the graded bedding. Let's say we've got the graded bedding like this, and then for argument's sake, let's just then let's say these are the fine grains, and then these are the medium ones. These are the medium ones. All right. So these lithological units. Okay, this lithological unit has been formed by the same processes, and they've been deposited at the same time as the river was carrying sufficient amount of sediment, and then when because of the sufficient energy of the current, when it loses the energy, then the bigger ones they get to be deposited until we've got the finer ones, because finer particles they need the calm environment. All right. Now, so when we're looking at all these rocks that belong that they are from the same lithological unit, they can still be what we call the when viewed under macroscale, they can still be homogeneous. All right. Yes. So I hope it makes sense. Then let's check now what we call the heterogeneity. Oh, Okay, let's first look at the homogeneity. Like I said, I gave you example of the monomineralite. It's homogeneous because, you know, it has got the same composition, the same texture. All right, then even this one can see it's in terms of composition, it's all black. Okay, then yeah, so it can you can see it's homogeneous now. But let's look at these three scenarios: the outcrop, the core samples, and the thin section. All right, at the macro scale, if we are looking at the rocks that they are from the same lithological unit, they would appear homogeneous at macro scale. And then when you're looking at the core samples, and then at the meso scale, they still look homogeneous. I mean, you see the same thing. All right, and then more or less the same and at the micro scale usually, but micro scale, you know, it's not usually it's not easy, but if they have the same chemical composition, for example, here you can see the minerals appear to be having the same chemical composition, which is why they seem to be homogeneous. So the homogeneity, it's about the rock appearing to be the same, all right? And then all the homogeneity is also the function of what you call a scale. So you'd agree with me that the scale is very important in structural geology. So as the structural geologist, you need to know your skills. Now, heterogeneity, on the other hand, refers to the variation of composition, texture, and structures. All right, and then at the macro scale, the rocks can be heterogeneous due to the presence of minerals, you know, inclusions or other features that are not visible at large scales. I mean, you know, that when you're using the petrographic microscopes, you can see the inclusions, you know, you can see inclusions of plagioclase, you can see the zircon inclusions, many other inclusions can be seen. You can see different minerals ranging from felsic to mafic. You know, let's check out the granite. You can see quartz. You can see feldspars. You know, you can see different minerals within a granite. All right, or other features, other, you know, textures that can be seen. So this is because now under the micro scale, at the micro scale, you are now zooming deeper into that particular rock. You're gonna see. Remember, naked eye can see things as being homogeneous. All right, but now that's because that's how far your eye can be able to see. But now, with the help of microscope, you can see right within that particular rock. You can see different minerals, the inclusions, and many other features that can be seen. Now, at the mesoscale, rocks can be heterogeneous due to the presence of bedding planes, due to the presence of joints, and other things. And, you know, remember, joints are just the fractures that underwent no movement. So the joints and fractures are the same thing. All right. Or joints and folds rather. Folds are those fractures that now underwent a particular movement. And then you can also see the bedding planes. You can also see the bedding planes. The bedding planes, those if you've got I hope you know the bedding planes. If you've got these beds, then the bedding planes will be this one. The bedding planes will be these ones. So the mesoscale rocks can be heterogeneous due to the presence of bedding planes. I mean, bedding planes will be separating different units or the geological units. So it shows that moving from here to there, you see the heterogeneity, but from here to there, you can see the homogeneity. All right. So all they depend on the scale. Now, at the macro scale, on the other hand, heterogeneity can be seen due to the presence of lithological units, okay, structural features or other large scale features that are not visible at small scales. Now, you can see the heterogeneity due to lithological units that are different, and then, you know, other structural features that cannot be seen at the small scale. Okay. Now, yeah, let's check this heterogeneity, the micro scale. You can see we've zoomed in into that particular thin section. We see different rock, different minerals rather. We see the plagioclase, we see the plagioclase. We see the, what's my, you know, we see a lot amount of the we see the Carlsbad twinning here. We see the orthoclase. We see the I think it's plagioclase with the olivine and many other things. Clinopyroxenes. We see many other things. This and these things, they've got different colors. They've got the different physical and optical properties. So it's heterogeneity when we are zooming into a particular thing. But now in under the mesoscale, when we, due to the presence of the bedding planes, we can also see the heterogeneity. All right. Now look from here, from the bottom to the top. All these things, this layer, it's a bit, I don't know, it's a bit brownish. All right, unlike this one at the bottom, unlike this one is a bit reddish, this one bit purplish, kind of like, so we see the heterogeneity because of this the presence of the bedding planes. But now at the macro scale, when we're looking at macro scale, you can at a larger area, remember you're not zooming into too much, but we're looking at the broader context. You can still see what we call the heterogeneity. So which is why we say heterogeneity as well, it's also the function of what you call the scale. Hence, the scale is very important in geology. But now let's look at this phosphatic sandstone. At the mesoscale, it's homogeneous. Can you now see that when you're looking at the sand particles, they all look the same in terms of the mineral composition, in terms of the texture, in terms of the sorting. They're all well sorted. They're made of the grain sizes, the same particles of uniformly same size, or approximately of the same size. So at the mesoscale, this sandstone it seemed to be homogeneous. But now let's look at the macro scale. Now we are zooming into it. Then we see that no, man, this thing is heterogeneous. We see different minerals with different with different composition, different textures, different other optical properties. Now can now see that now as a structural geologist, you need to understand your scale, because a sandstone here presented to you, it's under a mesoscale, it's homogeneous. But now, why when we look at that at the microscale, it seems to be homogeneous? Can now see that, okay, you must not look at one particular scale and then do a conclusion. But as mentioned in the second lecture of the structural geology course, that no, we need to combine the different scales so that we come up with a solid conclusion, and then for a particular rock, or for a particular geologic process. Okay. So scale dependent properties. Rocks exhibit scale-dependent properties that are influenced by their heterogeneity and homogeneity. These properties include the mechanical, physical, and chemical properties. And in chemical properties, we talk about the reactivity and the solubility. Physical properties, we talk about the density, the porosity, and then mechanical, we talk about the strength and toughness, right? I mean, if the rocks are strong and tough, means and we are looking at what you call the mechanical properties. But if those rocks are heavy, they've got some pore spaces, then we are looking at the physical properties. And let me give you example. For example, let's look at the porosity. I mean, if we've got some pore spaces, and then through that pore spaces, if we precipitated some some minerals, okay, some minerals from the groundwater in the process called cementation. Now can now see that that particular sedimentary rock can now become heterogeneous, right? Can become heterogeneous, right? So, and then in terms of for example, solubility and reactivity, we understand that if we dissolve some certain materials in certain country rocks, that country rock start to change in terms of composition, start to change in terms of composition, or start to alter. Now it may become heterogeneous. We can convert a homogeneous rock into a heterogeneous rock. So we've got different ways in which we can convert heterogeneous rocks into the homogeneous rocks into the homogeneous, or the opposite can be true. So all these things, they are scale dependent properties. They are scale dependent properties. So they are also a function of scale. Now, implications for geological applications. This homogeneity and heterogeneity, they are also good for, for the resource exploration, for the environmental assessment, and for for engineering applications. So for engineering applications, the scale-dependent properties of rocks have significant implications for engineering applications. By understanding how rocks change at different scales, engineers can design more effective structures and infrastructures. I mean, you'll be understanding if the rocks are stiff or are rigid enough at this particular area, right? So if now all of these rocks, they are rigid and they're stiff, then we know that particular area is good. It's good site for building some malls and many other structures. And then we know that those structures will be will be how can I put it? But will be safe to be used by people, because now those particular buildings will be um, will be good. Yes, will be good. Will not fall the next 10 years, right? That will be good. And then now, for environmental assessment, the scale-dependent properties of rocks also influence the environmental assessment. By understanding how rocks change at different scales, scientists can better predict the involvement of pollutants and contaminants through the environment, right? And then for resource exploration, understanding the scale-dependent properties of rocks is crucial for resource exploration and extraction. So by recognizing the differences in heterogeneity and homogeneity at different scales, geologists can identify potential targets for the exploration. All right, so this brings us to the end of the fourth lecture in the introduction to the structural geology. If you are liking this series, please don't forget to like, share, comment, and subscribe to our content so that we keep producing this kind of a content. So in the next lecture, lecture 5, we are going to be now looking at the continuity and the discontinuity in structural geology. See you on the other side. Until next time, cheers.